Well, welcome everybody. I hope you're having a good Tech Tactics so far. I got to say there's been some pretty good presentations so far. This morning, right out of the bat, watching the Manti one, I got to say I was lucky enough to actually drive a car with that kit on it. We were over in Germany for the Macan EV and the GTS introduction, or Train the Trainer as they call it. And we got to drive those cars around a track. And so they had a slew of different cars. They had Caymans, they had 991s, 992 GTSs and everything, but they had this one 9912 with the Manti kit on it. And I'll tell you what, all the cars were great, but you got into that car and you got behind the wheel, and shortly down the road, you felt like Superman. That car was so planted, like you can do anything with it. I was convinced at that point. I mean, it really, they're not just talking the talk, they are actually walking the walk with that car. It's an amazing vehicle. If you ever get a chance, please drive one because it's amazing. Anyways, my name is Tom Anderson. And what we're going to do is we're going to talk about the 911 Carrera GTS. It was a new model in 2025. It's pretty much the same model for 26, unchanged, and it's a very unique car. It's really a singular vehicle from a development standpoint that Porsche has in its lineup. It's even different than the newest of the new, which now we have the twin electric turbo 911, right? But even there are differences with this car than there are with that car. So we're going to run through basically the electric drive of the system. That's going to be topic one. So we're going to run through all of those particular items. And then we are going to run through the engine and some air-fuel ratio. And what they've done to this vehicle to make this thing meet emission standards and pending emission standards in other countries, okay? And that's what really makes this car unique. So the fact that we have taken a 992, which is a great car with just a combustion engine, and we've just added this electric system to it, okay? That alone, I don't think is even the most interesting part. I think it's the way they melded both of these items in order to meet a particular development goal. And to me, I look at it as typical Porsche, because Porsche doesn't really wait around until the last minute to do things. When there's things on the horizon, whether it's mandated by laws or legislated by different countries or whatever, they jump on it and they get the ball rolling and they come up with what they feel is the best solution. Well, in this particular case, because it is a 992, it is our premier sports car for the most part, this car needed to be made without downgrading any of the performance. It had to perform. It has to perform better than the last one, okay? So that was one of the main development goals, and they definitely achieved it and met all the other goals that they were needed to meet along the way. So, of course, we have a car combustion engine, which is an all-new combustion engine. It's not even the same as the old 992 Evo motor that we had, or 92A Evo motor as it was called. It's completely new. And then, of course, we have the best of both worlds. We have continuous performance with the internal combustion engine, like it's a regular 992, but we add the excitement of the electric drive. So that gives us boosting. That gives us, with our electric turbocharger, it gives us instant boost. So no turbo lag, for example. So combining these two systems really gives us a car that can perform on the road seamlessly and very exciting. But this is not a plug-in car. The engine is always running. So there's no place to plug in and charge the battery. And unless you're up on all the nomenclature, you know, all the manufacturers, they call their car something or they give it some numbers, and from that you can derive what engine's under the hood or what package is on that vehicle as far as options and whatnot. So if you don't know that the 2025 911 Carrera GTS is a T-hybrid, okay, one way you can tell is if you get inside, you will see a battery symbol in your tachometer. Maybe you will notice it from maybe some badging on the car, but on the back it's just going to say GTS. Now it does say T-hybrid on the door, but some people take badging off. Other than that, you're looking, maybe if you're pulling covers up or something, you might notice some orange lines from the high voltage system. Maybe you'll see some stickers on some components that say, warning, stay away. Okay, so these are all ways you can tell, but basically from the driver's seat, you're going to have this. So it's always good to know when you're operating a car or driving one, maybe your friend loans you one, you know, what it is that you know, you're driving or what's under that hood. So what's under this hood is not just a combustion engine, but we also have two electric motors, one in the transmission and one in the turbocharger. So some other things to consider. This is a 400 volt system. So this is plenty of voltage. All we need is greater than 60 volts or 30 volts AC, 60 volts DC, and it will be life-threatening, okay? So for sure, do not perform any work on this car without proper qualification. So if you buy one or already have one and you don't have any training, please take it to the dealer, okay? Also, persons with medical devices should not work on this vehicle. Electric vehicles, whether it's this one, a hybrid, all electric like a Taycan or a Macan BEV, they can produce some big electromagnetic fields that can, if they are exposed outside of the shielding, the protective shielding we have with the vehicle from taking it apart, can interfere with medical devices, implanted insulin pumps and pacemakers and whatnot. And that also can be hazardous to your health. So, yes?
Would that include working on brakes?
No.
Okay.
No, absolutely not. No. This would only be, for the most part, if you were possibly running the car, let's say, and like I say, we have a shielding system in all of our electric vehicles where the electromagnetic fields are suppressed by the shielding system so they don't go. For example, if we didn't, one of the biggest things that would probably annoy you is your tire pressure monitoring wouldn't work. It would interfere with it, right? So it's not just protecting anybody, even with these, can buy, operate, and run the car, okay? But you don't want to take it apart, especially the electric machine. We run permanent magnet, synchronous brushless motors, and if they are unbolted and taken apart, you have a big magnetic field around that. Not only don't you want to get near it if you have any of these, but your phone, for example, you'll wipe your phone if you get too close to it, okay? So they're that strong. So it's just a word of caution that these are hazard types that can go along with these high voltage systems, electrical, chemical, thermal, mechanical, secondary. That would be like secondary accidents if somehow you would get a shock or something. You could fly back and hit your head on something or trip on something. So, you know, you need to respect the vehicle if you have a hybrid, a BEV, or a T-hybrid, okay? If you don't have the qualification, please do not work on the vehicle. And of course, other ways you can tell is if you're looking at components, you know, stickers warning you don't open up or caution high voltage, like this is a big one right here, and so on. to just let you know, to give you a little warning that you shouldn't mess with this. But basically you say do brakes. Well, when the car is turned off, the contactors in the battery are open. So basically the car is shut down. The only place we're going to have electricity is basically inside the battery. So you should be fine doing brakes on that car without any problem. So respect the high voltage. So here's the basic layout of the vehicle. And this is pretty much similar to, I could put up a diagram of this, of a hybrid for the most part, any of our hybrids, and it's pretty similar. We have a battery, and from there we have traction lines that run back to a high voltage distributor. From there, the voltage is going to be transferred off to other components. So for example, the pulse inverter. Then the pulse inverter, our electric motor for the transmission, that's going to transfer three-phase AC voltage to that. Also from here, we're going to send voltage to the DC-DC converter, and we're also going to send it to the electric hydraulic PDCC pump. So that's a new item that they did with this vehicle. No more belt-driven hydraulic pump on the engine. And of course, we're going to send power to our electric turbocharger, all very important. So this battery up here is where they put the normal 12-volt battery. So does anybody know what they did with it? We still need a 12-volt battery in this car because, what's this? Yeah, you're right. Absolutely. Underneath the rear cover, in the rear, we have a newly designed 12-volt, 40-amp lithium iron phosphate battery. So that's the same cell composition that we've been using in the cars prior to this, where we have, in the Cayenne, or if you had a 992 with rear axle steering, you got the lithium iron phosphate battery in the vehicle. They're very light, and also they're a very safe composition for making cells, okay? And also we have in here is all these batteries have safety shutoffs in them, that if the voltage falls to a certain point, they're going to open up and they're just going to disconnect for safety, because we can't allow that voltage to go too low. It could be damaging to that battery. So for that reason, up in the front around the high voltage battery, we have our normal, which is not in the picture, but on this left front shock tower, there's a ground lug for your charger. And right here behind, you can see a red cap where you can hook up a regular battery. And what that's going to do is it simply closes the contactor, okay? So you simply take a regular 12-volt battery, hook it up. It will close the contactor if it did happen to open. And once it's closed, then you'll be able to, run the vehicle and charge that battery up again just from operation. Yes, sir?
Explain the EHPDDC pump.
Yes.
What is that hydraulic pump pumping fluids do?
The Porsche dynamic chassis control, okay? And the optional front axle lift, okay? So, it's just kind of a picture here. There's no easy or quick way to disconnect this battery. If you have to, you will have to pull the rear shelf. You will have to disconnect the ground line here like you would on any 12-volt battery. Yes, sir?
What's the expected life for both of these batteries? So there's something...
I would say lifetime. I don't think they made it and said, well, this is only going to last 2 years. Technically, if you take care of your high voltage battery in any vehicle, okay, follow all the instructions in your owner's manual, for example, you will get the maximum longevity out of that. And that involves not only how you store the car, at what state of charge, it also what temperature you store it at, also how much you charge it up. Now, in the case of this particular battery, we don't have any exterior charging. All the charging is being handled by the vehicle itself through driving it and whatnot, okay? But there are still recommendations within the owner's manual. For example, if you are going to be storing it for a certain amount of time, they like 30% state of charge. If you are going to be storing it for X amount of time, they actually want you to run the car in sport mode, and that will activate charge, and they want you to get it up to 80%. Okay? So if you follow all the recommendations of Porsche, you should get the maximum longevity, whatever that is. And I think all of these cars, all of them from the beginning, were built on the expectation that these batteries, if they're properly taken care of, should last the life of the vehicle. Okay? Now we know that's not true. Things go wrong. Cells go bad, electrical connectors go bad. There are various things that can go wrong, but there is no particular failure time on any of these components. Yes, sir.
I was wondering if these cars document driver speed.
I'm sorry, one more time?
Driver speed, do they document driver speed?
Driver speed?
Yes.
Not that I know of, no. I think that's only if you have that progressive dongle in, right? So anyways, so here's your, yes, sir.
If you own one of these cars in the Northeast and you're making your cars and they become garage queens during 4 or 5 months of the winter, and you can't plug this in to charge the battery, how does one charge those batteries during that period of time?
Well, that's the thing. You don't really have to. On the high voltage batteries, if you store them properly, and Porsche recommends that all of the electric vehicles are stored in a climate controlled environment, okay? And that's even a garage that's attached to your house that is not, let's say, directly heated. That's still better than outside at 0 degrees, okay? But high temperatures have more of an effect on it than low temperatures. So certainly during the summer, for example, your garage is probably staying a lot cooler, okay?
So the specification that you run it X number of hours or period of time.
Right.
If the car is unused for that 4 or 5 months in storage, there's no plug-in that keeps that high voltage battery.
No, that's why I say if you look in the owner's manual, it's going to direct you to, let's say, sort of calculate the amount of time you're going to store that vehicle. And if it's a short period of time, 30% is great. If it's going to be for a much longer period of time, I believe they recommended 80% on the battery. So you can just choose one of those two and you should be fine. You shouldn't have to worry about it, okay?
If it drops too low, what do you do?
Well, it shouldn't be dropping. If it drops too low, you might have a problem or something. It should be stable. Let me give you an example. We have a...
To lithium-ion batteries, and they're like about half the capacity when it's down at freezing or freezing below.
Yeah.
And if they drop down too low, they can burst open just like they can when you overcharge them.
Well, I don't think that's happening, to be honest with you. I think what happens is temperature affects the cells in any high voltage battery. The cell chemistry can affect it, what's going on, the temperatures, and that depending on the state of charge and the temperature, okay, can have an effect on the cell, whether or not it's going to, well, it's slowing down basically, to address what you're saying is, it's going to slow down the chemical process. So for example, you have a Taycan?
No.
Oh, okay.
I've got an awful lot of knowledge of lithium batteries.
Okay, all right.
And like the gentleman said, what do you do if it drops too low? How do you start the car if the battery is too low?
Well, on this particular car, we don't start the car if it's too low. There is a bottom limit for this battery, and the reason is we, like any hybrid, or even if it's a BEV, obviously, we don't have an engine, but any hybrid, okay, we use the electric machine in the transmission in order to start the engine. That's our starter. So we don't need to have an extra piece of equipment on it. Therefore, it's up to you as the owner of the car to keep track of how much is in that vehicle. But the car with its operating modes is very well set up to keep it above any of those levels. It's nothing that you need to like wake up in the middle of the night and worry about, does my battery have enough charge for me? It will have enough charge for you, okay? As far as storing goes, just to give you an example, we have a training battery here that we got in, I'm going to say the fall of 2013. And we received that battery at 30% state of charge. It was approximately 381 volts. So it was a second generation hybrid battery. And we've been training with that battery now. It's 2026. What do we got? About 13 years on that battery. It is at 29% state of charge after all that time. And it's only dropped to 379 volts. So that's how stable these batteries are when they're properly stored. That's not the case if you store them at 85, 90 degrees, for example, and higher temperatures have more an effect than lower. Yes, sir?
Last question on this, I promise you.
Sure.
Looking at this from the design point of view, you can argue that a garage queen car for 4 months, 5 months, without being run, is going to turn on and batteries in great shape. I don't know if that's true, but assume that it is for the moment. What was the design to just build in an external source of charge? Is it weight? What prompted that design?
Well, it's not just weight, it's also the total package of the design. So let's continue on and let's take a look at the battery and some of the other components, and that might become obvious. And if not, please ask again, okay? So, for example, there's our 12-volt battery. So if we start off with our battery, first of all, this battery here is only meant to supply voltage to the components we're using. It's only got a 1.9 kilowatt hour of gross energy. So, for example, the newest Taycan, which is all electric, I realize, but it's got 105 kilowatts because we're driving. We need that reserve capacity to power the car down the road. The newest hybrids we have 25.9 kilowatts. So we can drive almost 50 miles with just electric. We cannot use this battery for driving on pure electric. It wasn't meant for that. It's meant to supply voltage to the components so we can use those, okay? So in that case, we have almost 400 volts, 5 amp hour rated capacity. It is a nickel manganese cobalt cell chemistry, which is different than our 12 volt. And we have 216 cells, and they're cylindrical cells. This is the first time we went back to cylindrical cells since our very first hybrid, which was nickel metal hydrate on the Cayenne. But these cells, first of all, cylindrical, have, for their size, handle the most amount of energy, okay, versus the other types of cells that we have, like prismatic or even pouch cells. Okay, so this was perfect to make this battery the size it is. In fact, I'm sure somebody out here has a Cayenne that has a bigger battery than this. As far as a 12 volt goes, it's not a very big battery whatsoever, but it supplies the voltage we need to the other components so that we can operate this with the electric boost and drive, okay, and the other functions that it needs to do. Now, like all high voltage batteries, the contactors are in here. So you turn the car off, the contactors open. You turn the car on, they close, they send power out of our connection here, out to our distribution, our distribution box, and then off to all the other components. We always have a low voltage connection there. We are in the low temperature cooling system because we do have to make sure that the battery stays within a certain temperature. Any hybrid vehicle that we have thermal management on it to make sure that we're taking care of the battery while it's in operation or even sitting, for example. So if you have a Taycan and you pull up to an 800 volt charging system, for example, you plug it in, that's going to generate a lot of heat. Also, we want to make sure that that battery is charging at the proper temperature, which is going to be somewhere around 86 degrees Fahrenheit. So that way, not only will it be the gentlest, best charging for that battery, easiest on the cells, but it will also allow it to charge the quickest. But even here, because the car is charging and we are discharging these cells, the same things apply. We want to keep this battery somewhere between 86 degrees and maybe at the upper end 104 degrees. If it's a really hot day or you're somewhere in the desert or something along those lines, okay? So very, very well regulated. Of course, we do have a pyro fuse inside in case of some sort of a fault. So you get in an accident, the airbags go off, boom, it's going to open it up and cut the electric power to everything, because that's going to be the safest solution to make sure something in the back of the car, for example, doesn't, end up grounding out and getting high voltage against the chassis. Yes, sir?
Is there a single pyro, or is there 212, 400, or just?
No, there's no 12 volts in here. This is all 400. It is just in line with the negative contactor, okay, for the negative potential, and that's it. Once it opens that, the battery's open. There's no voltage anywhere in the vehicle for safety.
Both systems share the same primary ground. That's why that pyro is good for both electrical systems.
Well, the pyro fuse, think of it as a link within the high voltage circuit, but there's no connection between high voltage and 12 volt and low voltage. We are absolutely separated. In fact, you could look at any of our hybrids, this car, any of our, even our Taycans, our Macans, you can just think about all that high voltage. It's just floating around. It has no connection to the chassis whatsoever. There is no technically ground for that high voltage to the chassis. That's 12 volt territory, okay? High voltage is completely separated or isolated, okay? We build the cars with a network called the IT network, and they are isolated / insulated from all conductive housings, okay, so that it is safe to operate and safe to drive and whatnot, and many other reasons too, for fault, be able to find faults, et cetera, okay? So the pyro fuse is a safety thing inside. The other thing could be if there was maybe, I don't know, something inside one of the other components started shorting out, because we also monitor current draw. The engineers know exactly how much current this car will be drawing, and they have a current sensor in the system. If it exceeds that limit, it will open that pyro fuse, because they know the next thing that might happen could be possibly maybe something overheating, possibly an electrical fire. So many different safety systems are built into this and all of our other electric vehicles. So here is the high voltage distributor. We have two safety circuits in here. Now these are individual, just for individual components. So for example, the first fuse path is a 50 amp fuse, and this is just a straight fast acting fuse that they have in here. And it's going to be a 50 amp fuse, AC compressor, DC-DC converter, and the electric hydraulic PDCC pump. And then of course the 70 amp fuse, the second fuse path, is going to be for our electric turbocharger. So here's a case where we can individually protect these other two. The pyro fuse in the battery is for a total circuit or a total system protection, and then these are for individual system protections. But it is exactly what it's called. We're going to plug in right here, or right here, the traction line from the high voltage battery, and from there we're just sending voltage out to all these other components, because it's just the simplest, easiest way. The less wiring, everything, the lighter we can make the vehicle, and that's good all around. Yes?
What does the DC to DC converter do? Is it changing voltage like a transformer?
Oh, absolutely. Yeah. In fact, I think, nope, that's not next. We'll jump to that and we'll come back to the pulse inverter. So the DC-DC converter is going to neck down our 400 volts and turn it into 1200 volts. Okay? So basically, we have a transformer. This is going to be our 400 volt side. This is going to be our 12 volt side. And through the operation, computer-controlled operation of these MOSFETs, we are going to actually turn DC voltage, convert it or rectify it back into AC voltage. And then at that particular point, we have this transformer, and as you can see, they are not touching. This is called protective separation. Okay? I think maybe for the more scientific guys, I think they call it also galvanic isolation. Okay, same thing. But basically, there is, again, no connection. We are not touching our chassis or anything on the low voltage side with our high voltage. We are basically inducing voltage into the other side through a series of different size windings and whatnot. Okay? Once it comes over here, again, we have some transistors and we have some diodes. We're going to rectify, just like an alternator would on your regular car, back into 12 volts. And then with these capacitors, it's going to smooth that ripple out. And then we are going to charge our battery. We are going to have voltage available to do things like turn on your lights and all that other good stuff. Okay? The other neat thing about this is now what Porsche started doing is we have high voltage system pre-charging. Because we have these capacitors in the system, and in some of the units, in particularly this pulse inverter we're going to go back and look at, we have very large capacitors, and some of those things can hold like, can maybe even hold the 400 volts, okay? Before we can close the contactors when you want to start the car, we need to charge those up because capacitors charge very quickly. There's a very high amperage draw the second you hit the button to start that car. And if we would close the contactors right away, they would spark and arc. And that's going to induce resistance in that connection, and your battery would not last very long because the contactors would wear out. But if we charge them up before we close the contactor, then that means they'll close, but there'll be no spark, no arc. So all of our cars, we've done this on all the hybrids, all the electric vehicles, but we did it in a different way. We would have a separate pre-charge contactor, which was basically a MOSFET, and it would also go through a resistor, and we would slowly charge them up, well, slowly, fairly quickly actually, charge up those, and then we would finally close the contactor. But starting with this car, we are going to now reverse this process where we were taking 400 and we were necking it down to 12. We're going to take 12, we're going to reverse this, and we're going to neck it up to 400 volts and pre-charge all those capacitors. And then we're going to close the contactor with no sparks, no arcs, no damage, no resistance, and you're going to drive away and have fun in your car. So it does quite a bit, actually. It's a pretty amazing little thing. And we have them in all of our cars. So this is the new thing that we have, using the DC-DC converter to pre-charge the capacitors in the system versus having a separate pre-charge contactor in the e-box. Yes, sir?
A low temperature cooling circuit connect. So is this device liquid cooled?
Is it?
This box is liquid cooled?
Yes, we have coolant running through this box to carry heat away. Absolutely. But it's not connected to, it's the low temp. It's not connected technically to the high temperature circuit. Okay, there's a separation there. And we do, the thermal management on this, it does have a function where if things are too cold and out there, that it can funnel heat from the high temperature cooling system to help warm up the battery, okay? But then it'll quickly switch back into a cooling mode. And primarily to cool, we are going to not just use, have water running through this and the battery, but we are also we're going to be using the air conditioning system and something called a chiller in order to carry that heat away and then expel it at the front of the car. So the BTUs will go into the refrigerant, and then the BTUs will be expelled through the condenser at the front of the car as we run air through it. There is an emergency charging function. Oh, yes, sir.
The normal warranty is 48,000. What is the warranty on the system?
Oh, I don't know that. I did not look that up. So I don't know. Being a high voltage battery, I'm going to guess it's probably about the same. I don't think they're different for different cars. I think those kind of things are kind of standardized across the thing. So if your Taycan has a, I don't know, 120,000 mile warranty on it, or 9 years or whatever it is, this would probably have the same warranty on it. Yes, right. And then of course we do have, here's the battery B plus terminal that will go right to the battery that is underneath the rear shelf to charge that. Plug connection for low voltage communication, so CAN lines. There will be 12 volt power and all that for dictating its particular function. And then here a connection for the high voltage distributor to plug into it. So what else do we got over here? Yeah, that's about it. So let's go back now and look at our pulse inverter. So originally, when we were making these cars, okay, this component, the converter and the pulse inverter were one unit, okay? So, for example, the pulse inverter, we're going to run our high voltage into it, and then it's going to convert that DC into three-phase AC, UVW as we call it. Those are going to be the three phases that are going to power the electric motor. Well, the DC converter used to be internal to this component. We have now started separating those two components, so we simply call it a pulse inverter. But we used to call it a power electronics because it had both items inside of it. As you can see, this also can generate some heat through its operation because we are also connected to our low temp cooling circuit. We need to also make sure the temperature is good. But basically, this is not just converting DC into AC, but when the electric motor is used as a generator and it starts putting AC back into it for recuperation, we can then reconvert it back into DC to charge our battery. Okay, so it's working both ways, okay, but it's simply a pulse inverter. Now the electric motor is a little different, sort of like the battery compared to our other vehicles. So for example, it's 400 volts, it is still a permanent magnet, synchronous, brushless motor, but we have no external cooling for it. It's small enough it can cool itself. We don't have to run any water or anything to it. Okay, it can take care of itself. Other vehicles, we have those plumbed into our low temperature cooling system to carry the heat away. But it's only 63 kilowatts, for example, or 84 horsepower. For example, the newest Panamera, the electric machine, as we also call this electric motor, is 188 horsepower. Okay, so again, this is a electric motor that is incorporated into the PDK, which many different changes need to be made to this to fit it in, give it connections and whatnot. So the PDK had to be adapted to accept this electric machine, but it is there to simply help reduce the load on the engine and give you boost.
Okay, so that powers all directly to the drive. Well,
Yep, it's going to go directly to the drive. Exactly. Okay. Yeah. So the only other thing it'll do, if it's not powering or driving the car, it's going to recuperate and it's going to charge the battery. So AC compressor is pretty normal. We have a scroll compressor. It's electrically driven. And then the PDCC pump is now all electric. The rest of the system with the link rods that we pump hydraulic fluid in and out of the top and the bottom is pretty much all the same. We have a valve block for the front and the rear, but we're not using the engine to drive this pump. We're using 400 volts. So we have removed all that load from the engine, which is very important. And then, of course, we have the turbocharger. It has its own pulse, what do you call it? Pulse inverter on it, okay? Because again, this motor is the same as that electric motor, permanent magnet, brushless, synchronous, and we can either drive it or it can turn on its own and we can recuperate and it can generate electricity to also help us either charge the battery or run power directly to the electric motor in the transmission to help us drive down the road. Okay?
I got a question.
Sure.
The turbocharger,
Is it, who manages that?
The DME. The DME, yes, absolutely. Yeah, it's all in the electronics. So maximum power is only 20 kilowatts, about 1.3 bar relative, 105 maximum. This is a similar thing that they were running on the 919 hybrid. And the biggest part of all of this is so that we can maintain a stoichiometric air-fuel ratio through the entire range of this vehicle due to pending laws that are coming up in Europe called Euro 7, okay? So let's continue on now with the engine and the fuel mixture. So all new engine, it's now a 3.6 liter. We have a base 479 horsepower. With the combined electric, we are up to 564 horsepower, but the torque really jumps from 420 up to 641 foot-pounds. It's a beast. But to do this, there are changes that need to happen. We needed new camshafts, pistons, massive changes in construction. And all this is so that we could end up making sure this thing is running Lambda 1 through all load conditions. You can see the effects of hybridization. No starter motor, no separate secondary air pump because we need it for our catalytic converters to get them up to temp and start to working. But we can power our turbocharger and generate, that's our air pump now. So we don't need a separate one. No more valve lift adjustment. We don't need it. It's turbocharged, just not necessary. And that reduces a whole lot of internal friction in the engine by having all those individual little components. Switch to electrical components. No vacuum system, no belt drive. Literally no belts on this engine whatsoever. Absolutely nothing. Yes?
no alternator?
No. No, we have a DC-DC converter. That's what the DC-DC converter is. That's our alternator. Yeah. Oh, look at that. I didn't know that did that. That's pretty cool. I like that. Yeah. Okay, let's move on. Where were we? But because of this, look how flat the engine got. So you can see the old engine, the 9A2, belts and all that kind of stuff, AC compressor, PDCC pump and everything. But it's not just that. There's also other things like, look where the oil filter is. Now it's down below, okay? There's your alternator. Don't need it. Don't have it. Yeah. Not my area. But I agree with you.
I just see what the weight difference is.
Oh, overall, one engine to the other, it's about 4 kilograms lighter, okay? Which, 2.2 pounds per kilogram, right? But every ounce counts, right? Okay, so if we take the entire hybrid system, it's only adding 103 pounds to the weight of the vehicle over a standard 992, the old 992 from 2024. So that's pretty good, where they have saved weight. But this was actually very necessary to do this, because those components we were just talking about, guess where we put them? Right on top of the motor. So the DC-DC converter, the distribution box, the pulse inverter is actually over here. AC compressors up there as well. But it gave us all this extra room to put things.
So all of
Go ahead.
the components, a lot of
Whoops.
have to use a cooling system, correct?
The AC compressor is not in the low temperature cooling system at all, doesn't need it. We got refrigerant running through it. The PDCC, EH-PDCC pump also does not need to be hooked into the low temperature cooling system. It manages its own heat, but the high voltage components do need to be in thermal management. Yes, we need to control their temperature. So the engine went through drastic changes. They redid the entire engine block, for example, to condense, make everything shorter and more condensed. So for example, we now have a smaller oil filter that's located in the pan or underneath. We've also got rid of that up top additional components where the filter was. So now it's a shorter run for the oil pump to pump to that filter. Okay? We also, new cylinder heads, and we stuck with the central feed for the crankshaft. Okay? And then the oil water heat exchanger is also down inside the pan instead of on top of the engine. So again, a very short run to pump this oil. So for that reason, for this particular engine, they actually increased the overall pressure of the oil system, but they were able, because the runs are so short, to decrease the amount of flow. And what that does is it drastically reduces pumping losses, or again, friction within the engine. We're using less power to lubricate this engine, okay? What else do we got? Well, let's continue on. So here you can see the front. If we pull off this engine mount thing, there's no pulleys, nothing. But we do have, this is pretty standard that we know from the GT3s, right? But being a whole new case and everything, which, oh, and by the way, the case itself is even shorter. It's more condensed, okay, even though it's a bigger displacement. And the reason they went with a bigger displacement is because an engine with more displacement can produce more power that's sustainable. So when we do have to cut back on the amount of load that the engine is going through, which load is nothing more than how hard is the engine working, and then supplement it with electrical power or boosting from the electric machine, for example, it's easier to maintain a certain level of power, okay? But to do that, there are other things. But here you can see we are feeding our connecting rods through the center of the crankshaft, which we have done for quite a while now. Here's another good look at what's going on. Engine's upside down. There's our oil pump. There's our oil filter. There's our oil water heater. But look, we also have our coolant pump down there. Okay? So they're basically driving the coolant pump with the oil pump. So one drive, we're powering two things. Okay? And that eliminated a separate external coolant pump. Also, there was multiple crossover pipings and whatnot to go from one bank to the other. It's all internal now. So all those extra pieces, it's more condensed, and they also made the cooling concept inside the block and the cylinder heads better in order to help cool it more efficiently. Okay? New camshafts, no lift. Okay, they're lighter. Also, no more high lift. We have a new cam actuator with basically like a tension spring in there. That also helps to reduce operational friction, okay? We have our new magneto-resistive sensors, and those are super important for this concept because old sensors that we used to use, which were Hall sensors, we could take every 360 degrees, we could do 4 readings of where those cams were. Well, with these, okay, we can determine where the cams are 120 times in 360 degrees, to where they can almost calculate exactly how far a valve is open. They can calculate cylinder filling and everything else that's important for determining fuel mixture and fuel ratio as far as injection goes. They first came out on the 24 Cayenne S when we went to the back to the 8-cylinder, right? The 825 Evo motor. And now they are pretty much, they're going to make their ways to all the other cars. Put roller rockers from the GT4 on it, okay? So to eliminate also friction at that particular place. So everything they've been doing is to make the engine more efficient and use less energy to actually operate, okay? Yeah.
What do you mean no more valve lift?
No more additional valve lift. We would have small lift and then high lift, okay? All right, so for example, a traditional valve, we have a couple different types depending on the engine, but the traditional one is at lower speed ranges, your valve lift would be 3.6 millimeters. Once you got to a certain RPM, okay, it would trigger a lifter to lock the valve lift at a higher amount, which is generally somewhere between 10 and 11 millimeters, okay? VarioCam is this. The Plus was the lift, okay? So VarioCam Plus was at traditional systems. And like I say, there are varying, some varying amounts in different systems on that. So, of course, these need to be programmed. There's a new tool, but that's basically for the, what do you call it, for the shop to worry about. New pistons. Because the peak combustion pressures increased with this, okay, they had to come up with a piston that was a little bit stronger. So these pistons are made out of an alusil material because they're kind of hard as rock when you cast a solid piece like this. The exact metallurgy makeup, it was too long, I didn't put it on here. Anyways, but the oil jets will spray into this hole, as you can see. And this is a cast-in duct, and then the oil was spit out on the other side, and it takes away all the heat around the ringlands, okay, to help keep this piston at a cool temperature. Therefore, when working on it, it's very important that you make sure you don't bend any of these jets. They're screwed in, so best practice would be remove them, do whatever work, put them in last. That way you don't worry about screwing them up. But this is good for piston cooling.
What's the compression ratio?
I think this is 9.2 to 1, yes. What do we got here? Oh, on the other side, they put in a oil pipe chain tensioner, they're calling it, but basically what it is because gravity also has an effect on oil when you turn a car off, right? It can help, you can get the scavenging effect, and gravity can pull in oil and help to empty some oil ducts, even just partially. This thing will, this little thing here will fill it, and it kind of puts a stop to that. Therefore, the upper chain tensioner, the lower one doesn't have to worry about it. It's already down here. Gravity's pulling oil to it. But gravity could pull oil away from this thing, so this prevents the scavenging effect to pull oil out. So basically, you start the car, that thing will never be, let's say, low on oil. You'll never get a small rattle or anything out of it. So that's just a good thing to have on the engine. The exhaust, we have not one, but there are actually 2 3-way cats in there, okay? you can see we have this one here, we have a very long exhaust coming over into our turbo. This is a shorter span, okay? And all the cars are running a gasoline particulate filter now. And these things are very closely related as far as their function, and also very closely related to running at lambda 1, okay? Differential pressure sensors are what are going to monitor that particulate filter if too much ash would build up and it would, start to, let's say, clog up because it never was able to convert the ash back into O2 or CO2. So if it wasn't able to burn it up, so that's how we do it, pressure before and after the particulate filter. We use 3 wideband oxygen sensors because, again, the unequal lengths of these exhaust paths, we are basically double checking each bank for how they're running as far as their fuel mixture, okay? So after that, we have a final one. This is the third. They call this a Y concept. And then finally, we have a narrow band after the cats, and that's always our diagnostic one. It's going to check to make sure that the cats are actually working. It's going to be making sure that they're holding on to the oxygen that they were designed to hold on to. Now, the laws involved with this vehicle, okay? So there is the Euro 7, it hasn't been enacted yet, and nowhere in that law does it specifically say that cars need to run at lambda 1. But the engineers have decided that basically when you read that law with the emission constraints they're putting on the vehicles with Euro 7, the only way to do this is by making sure the vehicle runs through all of its load ranges. It stays at lambda 1, which is basically a perfect 14.7 to 1 fuel air ratio, okay? So some of the things they had to consider. This is a Porsche, so without some kind of compensation, we were going to have a specific loss because there are systems, like for example, water injection could do it, but car's not going to perform. That'll cool the combustion chambers, but that ain't going to work. Just EGR, again, that's going to suck performance out of the vehicle. Variable compression, again, Miller cycle with variable cam timing. Again, that's not really a performance system. That's an efficiency system. There's other variable systems they could have used, but this is a Porsche. This needs to perform. So they decided to go with, well, we're going to make a new engine. We're going to go with a bigger displacement. We're going to kick up the pressure. We're going to have to kick up our cat volume, sound damper volume as well. And we're going to add a hybrid system to it, an electric, to basically assist and reduce or change the load point of the engine where it's needed. So where is it needed? This is the old car. This is the new car. You can see every car that's on the road, even though we have wideband sensors, we never turn them off. We always have to enrich in the mixture to make sure we cool the combustion chamber, to make sure that we don't overheat components, we don't damage cylinders, pistons, valves, turbochargers, all these components, okay, from too much heat, or we get into pre-ignition, or we get into knock, or we generate too much NOx, which is a really bad, obviously, pollutant gas, okay? So this has always been the accepted thing, all the way up through 24, everybody does it, but this car can do this. Because when the engine is working too hard, we can throttle back on the load of the engine, the power of the engine, and we can throttle in electric assist. So you don't even know that that happened. You just think, you can hear the engine running, you're having a great old time, it's got a good exhaust note, but, okay. So you don't even know that happened, and basically we're able to run lambda 1. So I'm just going to run through these really quickly. So regenerative load point shift. So here's a case, you're driving the car and the electric machine is just simply switched into a motor and we're charging the battery, okay? Here's one where we're just using battery to assist the electric motor to actually propel the car, okay? And then here's one again where we're on the brakes, so we're not driving at all, but we are fully regenerating energy into that battery, okay? Here's another one. The turbocharger is simply because you can see the exhaust gases are hot enough, we don't need to power it. The exhaust, like a regular turbo, is spinning it, so we can take that energy, recoup it, and charge our battery in the car. But we're still accelerating, okay? Here's another one where we could be at, let's say, low RPM. We're just pulling out. We can spool that thing up and you can have instant boost. So you don't, there's no lag with this vehicle whatsoever. Here's one where we are actually boosting with both. We're spinning the turbo and the electric machine. So this could be, you're on the highway and you go to pass somebody, for example, but you've got your foot on the floor and you want to get up and go. Here's another one where we're driving here, but again, we have exhaust gas is hot enough that we're able to add to, not do the battery, but because we're booking here. We're in the upper load range, so we're flat out having some fun, but we're going to take that additional electrical power and feed the electric machine in the middle to keep us accelerating. Okay? And this is only a few. These are seamless. They overlap, and there's many more. You know, they didn't give us a complete encyclopedia of all these different modes, but you can see the possibilities here, and it works pretty darn good. And other than that, we have a car out here. I'll be out underneath. I could show you guys around. Yes, questions?
Can you go back? I think it's slide 12.
Slide 12, 34, 33. Oh, all the way back.
All the way back.
Okay, let's go back.
To answer the question, if the car, the 12-volt battery, I think go back to where you showed there was a ground point.
Well, here's a ground point for this 12-volt battery.
You could, if you needed to jump start the car with a 12-volt, in fact, I think you said this, you connect to that red post and to the other one, and you could use an external 12-volt battery to jump.
Well, first of all, this is a lithium phosphate iron battery, and the rules are different. Number one, they are designed that they get down to a certain voltage, the contacts will open to preserve the battery. We don't want to go too low or it can damage the cells. But we can close that contactor and make this functional again by simply hooking up a 12-volt battery there and then to the negative jump lug that's on the tower.
And so then you start the engine and it charges the battery.
Yeah, it'll close it and you can even pull it off. It's not going to open immediately, and then you can start the car is going to be started by the 12-volt battery. The 400-volt battery and the electric motor in the transmission, okay? But then everything will work. Like, for example, your ignition switch will now work so you can start it.
This is the way to, like, if that contact opened, you could get it to close by just...
Yes, by simply closing it, that's the procedure. And that's in your owner's manual as well. Yeah, not a big deal, so. Anyways.
So this is a totally brand new engine, more or less, right?
It's a whole new engine,
So
yes.
more or less saying that we should wait a couple of years before we buy this house.
No, I wouldn't. Yes, sir.
What's the cylinder liner? It's not Nickel, it's not Locustil, hopefully it's not Allysil. What are they doing to have a hard enough cylinder you don't have to worry about force point?
It's really not an issue. They're using the plasma transfer wire arc method. Okay, so it's basically an iron cylinder. Okay.
Tom, thank you very much.
Thank you.
Pleasure having you.
Thank you, everybody.